after talking about the trajectory equation, now we'll begin with the second characteristic اللي هي velocity vector. So we said in our lesson the main objective is to talk about the motion. The motion itself means talking about the position vector, velocity vector, and acceleration. So we finished the position vector, and then we need the displacement vector in order to study this average velocity vector. بالنسبة للvelocity vector, it can be divided into two parts. We can talk about average velocity vector and the instantaneous velocity vector. So we'll begin with the average. What do you mean by average velocity vector? So, in order to talk about a motion, we need to ask the question, in what direction is the object moving, what is its speed. So what the characteristic that talks about this question is the velocity vector, and if we notice, we said in what direction. So when we said in what direction, this means we have a direction. So in this case, we are talking about a vector quantity, not a scalar quantity. This is why we said the velocity vector and not only the speed or not only the velocity. So what is the velocity vector in general? It's the variation of the position vector. If you remember, when we said definition of the displacement vector is the variation of the position vector. So a velocity vector is the variation of the position vector. This is what we mean, it's the displacement vector during an interval of time. Then it's given by, according to this definition, v vector equal to the variation of the position vector in terms of per unit of time. So it's equals to the displacement vector, and this is what we call m initial, m final. So ليكون في عندي velocity vector, the object must be moving. Must be moving means انتقل من place, in a certain position into another position. So from an initial position into a final position. Then this is what we call displacement vector over delta t, which can be written according to delta t, according to the interval of time. For an interval of time delta t, we say that this is the average velocity vector. But for an elementary interval of time dt, means for a small, very small interval of time dt, then we will be talking about the instantaneous velocity vector. Now, average velocity vector, so the variation of position vector during a certain interval of time, then in this case it's given by v average between initial and final position, so which will be given in the exercise. Then it's equals to the displacement من وين لوين مش object during this time over delta t. So as answer, if you notice, it's a vector. So as answer, we'll have a vector, and we are talking in the x or y system, then it must be in terms of I and j. Now, so v average equal vxi plus vyj. This will be the answer, such that Vx and Vy are called the components of the vector. If we have now an example, represent the vector V average between 3 and 7. In order to represent it, we must have a system that's moving, so an object that's moving. This object is the ball, which is modeled by a point. So this is the object, it's a ball modeled by a point, it's the motion of this ball. Then second, we must have a system, a reference. So this system is the x or y system. So this is the reference, and now we want to trace V average between 3 and 7. According to the rule, V average equal displacement over delta t, displacement vector. So this displacement vector is m3, m7, and this is, if we notice, V average is equal. This means they have the same direction, same line of action. So if you notice here, this will be V average between m3 and m7. A revision, so V average, the average velocity vector, is the variation of the position vector with respect to time. Then this means the displacement vector per unit of time. Then it will be equal m initial, m final over delta t. This is what we call displacement vector. So it's equal to the variation of position vector per unit of time over delta t. Now, after doing this revision, we will start the application. So we continue the first application. We begin with OMT equal RT equal T plus 1I plus minus T squared plus 2TJ. This was the position vector R. Now the question is determine the average velocity vector between T0 and T3. So here, if you remember, we found the position vector at the instant t0, t2, t1, and t3. This was in the first question of this application. So now the question is, determine the average velocity vector. According to the definition, the vector equal v average equal delta r over delta t. We have between 0 and 3, so the final is r3 minus r0 over t3 minus t0. Then we'll have as answer its vector, which is equal to 1i minus 1j. So v average equal 1i minus 1j.